Alright, so this is what we talked about last time. So if you were gone, we talked about special products. So it's essentially what we did, but a whole bunch of shortcuts to what we did. Of course, you can find the video online to watch that lesson if you missed it. So, do you remember the rule for the first one? How do I set that up in one step? Yes.
Well, you have to split it up and then make it on like the opposite side. It's like 3x minus y times 3x plus y.
Kinda. This is the one where, remember, we have a minus b quantity squared, which is a squared, minus, so you do have a minus sign, minus, what goes in the middle, do you remember? 2ab, yeah. 2ab plus b squared. So, when I see something of this form, I can always apply that shortcut. So I'm going to do that. The first one squared is 9x squared minus what? Well, what's the two middle terms? 3x and a y. When I multiply them together, what do I get? 3xy, and then I have to double it. So when I double it, I get 6xy. Does everybody understand that? I take the a term, which is 3x, and the b term, which is y. I multiply them together, because ab equals 3xy, and then I double it. So 2ab equals 6xy. Now, the last thing that I do is I add b squared, which in this case would be what? Yeah. All right. What about the next one? We talked about, yes. No, remember that the only sign change between the positive and the negative. So if we had a plus b quantity squared, it's all the same except for the middle. So 2 plus 2ab plus b squared. So they both have a plus b squared. And that's because when we do it the long way, when we multiply, we'll end up with positive b squareds. Okay, the next one. Our middle terms cancel out, so that was something we were taught. We have a difference, right? We have a sum and difference of the same terms. Remember, that rule only applies when we have the same two terms. So I have a 4x and a 4x and a y and a y. So what does this simplify to be in one step? Yes, 16x squared minus y squared. If you weren't here for the thing and you didn't watch the video, again, I suggest that you do that, but just a real quick reminder here. If you have something of the form a plus b times a minus b, you will always get a squared minus b squared. Yeah? So that's what we did. Do you have any questions on those two special words from yesterday? Again, I think the hardest thing is to remember what happens in the middle with this, and also that the b squareds are always positive up here. Okay, we're going to start notes for 7-4, and we're going to finish them today since I will not be here tomorrow. But I will give you time tomorrow to work on the homework for tonight, and we'll just have a little bit more practice tomorrow. So tomorrow is just basically catching up on any assignments that you have missing in this class, any work from today, because it's a kind of long assignment, and just a tiny one tomorrow. Tiny assignment. Alright, so today we're going to start looking at factored form. And factoring is essentially reverse distribution. Factoring is a very critical skill in Algebra 1, especially in Algebra 2, and throughout all of mathematics. So this chapter is about laying that foundation. Do you know how to factor? In other words, we're introduced right away to two forms, standard form and factored form. We use Oh. Actually, I am recording, but it's on freeze. Thanks. I appreciate that. Okay, so, as I was saying, we looked at standard form. And so how we got to standard form is, of course, we used distribution property, you FOILed, whatever it is that you did to help you multiply two binomials, or binomials and trinomials, or trinomials and trinomials, to get standard form. And standard form, again, was written in descending order based on the exponent. So the highest exponent comes first, then the second highest, etc., etc. Now, we're going to go backwards. We're going to take something from standard form, and we're going to factor it. We're not really going to investigate the actual factoring part today. We're just going to be working with what we're going to get to in the future. In other words, we're going to be working with these factored forms. So it says a polynomial is considered to be in factored form when it is written as a product of factors. So in other words, if I have two binomials, if I have a binomial, each part of the binomial, if I have two binomials, remember binomials meaning two terms. So I have a monomial and a monomial, and x minus 3 makes a binomial. And then I have a monomial and a monomial, x plus 8 makes a binomial, right? Each of these binomials is considered to be a factor. Does that make sense? Just like x up here is considered to be a factor, x plus 2 is considered to be a factor. So essentially the things that you're taking the products of are each factors. So we have something called the zero product property, which we've actually talked about before. It says if the product of two real numbers is 0, then at least one of the numbers is 0. This is kind of a profound concept, but it's actually easy to do. This says that essentially, if I am trying to solve for something in factored form, let's say x minus 3 times x plus 8, those two binomials, I set that equal to 0. I can apply what's called the zero product property, which says that I can take each of these factors and set them equal to 0. So either x minus 3 equals 0, or x plus 8 equals 0. Our task is just to solve for x. So it shouldn't be that hard. But you just need to know what the zero product property allows us to do. It allows us to take something in factored form and take each of the factors and set those individual factors equal to 0 and solve for x. Why do we need to solve for x? Well, because when we start to look at graphing something like this, which turns out to be a quadratic function, it crosses the x-axis twice, or it can cross the x-axis twice. So we have two x values, which will be both times that your graph crosses that x-axis. Does that make sense? So you're not just dealing with a line where you can cross it just once. You're dealing with a parabola where you can cross it twice, maybe here and here. Okay. Do you have any questions about that concept before we actually start applying it? I know it's kind of out of your grasp maybe at this point, but once we put it into practice, I think it'll become easier for you. Alright, so we are tasked with solving the equation. We can use our zero product property to do what? How will I solve A using my zero product property? Yes. Exactly. I can set each factor equal to 0. So what would be one factor? Yep, 2x equals 0. What's another factor? X minus 4 equals 0. So my zero product property says either 2x equals 0 or x minus 4 equals 0. Both values could work. So it's important to know the difference between what we say when we talk about or in regular colloquial English, that means everyday talk. Like you can have a burger or fries. And oftentimes what we mean in mathematics when we use the word or. Just because we have or doesn't mean only one will work. They could both work. So sometimes you have to think of it as or both. Yeah? So when you solve for x for the first one, what do you get? Yeah. And if we check it, we see that that does work. So if I take 2 times 0, I get 0. And then 0 minus 4, of course, I'll still get 0, right? So that works. What about this one? X equals 4. So I can check it to make sure. 2 times 4 is 8. And then I have 4 minus 4, which is 0. 8 times 0 is 0. So that also works. Yeah? Remember, it doesn't mean one or the other. It means that either of these will work. X can be 0 or x can be 4. That's what they mean. Does that make more sense? Or in that sense. X can be 0 or x can be 4. Now what that means in a graphical sense, we'll talk about later. Again, what happens when I have a regular linear equation? Let's say y equals 2x plus 4. What am I looking for when I set y equal to 0? What's that called? Well, it's called a blank intercept. What intercept am I looking for when I set y equal to 0? The x-intercept, right? The point that crosses the x-axis. So I'm looking for those x-intercepts, right? So that means my parabola, this is a parabola, it will cross the x-axis at 0, and it will cross the x-axis at 4. Does that make sense? That's the point of this. When we get there, that'll make more sense, but we're just looking at the process right now. So B should be pretty easy as well. What are my two factors? B. Well, x minus 3 is the factor, right? Yeah. And x minus 9 is the other factor. And when I solve for x, I get 3, 4, x equals 9, and they both work. I don't know why I put parentheses there. Okay, any questions? Yes.
For the first one we did, I think you said how you check.
Oh, for the red, the one in red?
Yeah.
I plugged in 0. So I said 0 times 2 is 0. And then 0 minus 4 is just negative 4, right? And 0 times any number is just 0.
Oh,
So that works. That does get me 0. And then I plugged in 4. 4 times 2 is 8. 4 minus 4 is 0. 8 times 0 is 0.
but why did you plug in 4?
Because it was the other value of x.
Okay.
Yes. No, that's going to standard form. Right? We're working with the factored form, which is the form before we do all of that, right? Because in order to solve these polynomials, we have to get it in factored form. Oftentimes we can't work with standard form. So we have to factor things in order to apply the zero product property in order to solve for x. Does that make sense? I'm glad you asked that question. It's a great question. We don't want to go the other way around and set it equal to 0, because that is very difficult to solve for x. Okay? We work with factored form, so we have two factors, use our zero product property, and solve for x that way. Yeah? Okay, give those a try. One thing I want to say, a big issue that I see with a lot of students in Algebra 2, pre-calculus, and beyond is that they will factor something, meaning they'll get it into this form, and they'll be told to solve for the variable, and they forget to set it equal, or they'll be told to find roots, which we'll look at, or those intercepts, and they forget to set it equal to 0. So this setting it equal to 0 part really means something, like I said. It means when we're looking, it allows us to find those points at which our graph will cross that x-axis. So just keep that in mind for the future. I see that error a lot. They just forget that extra set it equal to 0 step. You'll be doing that a ton. So just for future reference, did you get these x equals 0 or x equals 1, t equals 0 or t equals -2, z equals 4 or z equals 6? That is a great question. Yes, and in algebra 2, yes.
Can we work out number 1 and
I can work out one of them. How about I work out number 2?
2? Okay.
Just for time's sake. So you want to set each factor equal to 0. So the first factor is 3t. The second factor is t plus 2. Well, when I divide by 3, solve the value of t, any number divided, or 0 divided by any number is 0. Remember L, K, and L. So t equals 0 for the first one. Or, when I subtract 2, t equals -2. It's just solving linear equations. Yeah, and to answer that question, in algebra 2, we look at things sometimes will have imaginary roots, sometimes will have 1 root, sometimes 2. It really just depends. There is such a thing as imaginary roots. Speaking of roots, what we found are roots. Okay, so those x values are called roots. The roots of our equation. What are roots? Again, those are our points that cross the x-axis. This is something that you'll talk about. This is just a special note here, but you will talk more about that in Algebra 2 and in pre-calculus. We have what are called repeated roots. So when 2 or more roots of an equation are the same number, the equation has repeated roots. So, for example, you may be solving for x, and you get x equals 1/2 for the first factor, and you get x equals 1/2 for the second factor. You have what's called a repeated root. And graphically, this means something. If we have even repeated roots, and I will not test you on this, it's just extra information that you'll need to know in the future. But if you have even repeated roots, like 2, 4, 6, so this occurs twice, right? If you get x equals 1/2 4 times, or x equals 1/2 6 times, that means that what's actually happening to your graph is that it's bouncing at those points. So it's going to bounce. That means that here, when they solved this equation, they got a repeated root, an even repeated root, so either 2, 4, 6, 8, etc., of -10. So it bounced at -10, and it bounced at +10. Does that kind of make sense? If you have odd repeated roots, meaning it appears once, or it appears 3 times, or it appears 5 times, etc., that means it's actually going to cross that axis. So it crosses at 5, or -5. So that -5, you either got that as an answer once, 3 times, 5 times, etc. Does that make sense? Yeah. So that's what's actually happening in our graph. And again, all of these points, yes, we call them x-intercepts, but another word for them are roots. Roots of our polynomial equation, and we refer to that when we're talking about quadratic equations, cubic equations, etc. When we talk about linear equations, we'll just call them x-intercepts. But anything beyond the line, we refer to them as roots. What are the roots of your equation? On some of these, you'll get repeated roots. Not all of them. So 2x plus 7, 2x minus 7. It's just 2x plus 7 equals 0. And you can write this down or not write this down depending on if you need it. It's just the same process. You just need to recognize that you can get the same answer. That's okay. 2x minus 7. So I subtract 7 and I add 7. So I have 2x equals negative 7. And I have 2x equals positive 7. And then I do what? Divide by 2. Divide by 2, divide by 2, I get x equals negative 7 halves, or x equals positive 7 halves. That's not a repeated root. Will I get a repeated root for b? Yeah. Why? Well, it's squared. What does it mean for something to be squared again? Multiplying it by itself. What do I notice about my two factors? They're the exact same. So I'm going to get x equals 1 twice. Right? That's a repeated root. It means when we look at this graphically, again, you don't have to know this, but when you look at this graphically, it's going to actually bounce. What are my roots here? We should be able to just tell right away. 3, 2, and negative 1. 3, 2, and negative 1. An easy way, think opposite signs, right? You're going to have to subtract 1, add 3, add 2. So that should be negative 1, positive 3, positive 2. Does that make sense? So I have 3 distinct roots, none of which obviously a distinct means different, so nothing's repeated. All right. Any questions so far about anything we've learned? Or is it all pretty simple? Good. Yeah, this is actually a really profound concept. So here are the answers. Oh, there's a 7 that I forgot. Did you get those? Good. All right. So we are looking at the greatest common factor. Well, again, that is important in factoring. Yes? So it says find the GCF. So we're not even going to start factoring this yet. You're just going to tell me what the GCF is. So what is my GCF?
Or no, 6.
Nope.
4.
4. Now, you have to add an extra bit of information here. What else do they share?
6.
No.
3.
They share x's, right? How many x's do they share?
2.
3.
3.
Okay? So when you're looking at your greatest common factor, you have to consider both the coefficient, the number in front of the variable, as well as the exponent. So this has 4 x's, right? X to the 4th, so it has 3, obviously, x to the 3rd. And this has x to the 3rd. So you want to just look at the highest one that fits both. Okay? Does that make sense? So if you're looking at, let's do another example. 3x to the 7th plus 6x squared. What would be your GCF? 3 what? 3x squared. Yep. Yeah? Okay, cool. Remember, GCF. Okay. Says factor out the greatest common monomial factor from 8y squared minus 24y. What is the greatest common factor? 8 what? 8y. And notice they call it the greatest common monomial factor because it's a monomial, but you can just call it the greatest common factor. Questions on GCF before we look at actually factoring it out and working with the form that we have left over? Okay. Thanks for being troopers, my dears. I appreciate it. All right, now we're going to start factoring. Okay, we'll go into the harder stuff in factoring next week, but this week we're just going to factor with GCF. You will, even next week, still take out your GCF. It's just that sometimes you have to go a step further. Okay? So it's just like when we're solving linear equations, sometimes it took just one step and we looked at that first. That's sort of the one step thing here before we get to the multiple steps and all of that. Does that make sense? So we have solve a, 2x squared plus 8x equals 0. Always start by taking out your what? GCF. What's my GCF for the first one? 2x. So this is what I'm going to do to factor. I'm going to say, okay, I took out a 2x, then I'm going to put a parenthesis, and then I'm going to ask myself, how do I get this? What do I have to multiply 2x by to get 2x squared? Just by an x, right? And then I put a plus sign. What do I have to multiply 2x by to get 8x? 4. Does that make sense? I just took something in standard form and I put it in factored form. Yeah? So now I can solve it like before. I set each factor equal to 0 and I get x equals what and what? Yeah. Perfect. Does that make sense to you? Okay, so we're going to do the same thing here. Now notice, this is the part where people mess up. Remember I said they forget to set it equal to 0? So what should I do to set this equal to 0? Subtract 15n first. 6n squared minus 15n equals 0. Now, I can look at the greatest common factor. Does that make sense? Always set it equal to 0 first, before you start factoring. So what is the greatest common factor? 3n. Remember, we're not just looking at the coefficients, we're also looking at the variable. So what do I have to multiply 3n by to get 6n squared? 2n. Remember your rules of exponents. It's okay, this is new. I put a minus sign. What do I have to multiply 3n by to get 15n? Yes. Alright. That's set equal to 0, so I can use my zero product property to solve for the value of n. Okay? So, 3n equals 0, n equals what? What? 3n equals 0. So divide by 3, n equals 0. Okay, 2n, you're solving another one. 2n minus 5 equals 0, which is also something you have to solve. So n equals what? 5 halves. So we have n is 5 halves or n is 0. Does this kind of make sense to you? You have to remember your rules of exponents. Because if you don't remember your rules of exponents, that's where you can mess up. Because you have to say what, remember, when we multiply exponents, what do we do with them? What do we do when we multiply to x? You add them. That's why I said, what do I have to multiply 3n by to get 6n squared? Well, an n to the first plus an n to the first is an n to the second, right? Okay. Alright, so here are the answers to those monitoring progress problems. Please make sure you've got all of these answers. Number 11, we will look at later. I will not be here tomorrow. You will have time to work on your assignment tomorrow. and have a great 3-day weekend.